Hello, and welcome to an introductory overview of FireScope SDDM, Secure Discovery and Dependency Mapping. My name is Gary Jones, and I'm a service engineer with FireScope, as well as your guide for an overview of our SDDM product. Today we will be covering the basics of how to use SDDM, some ways that it can benefit your asset management processes, and conduct a brief demonstration of how it can be providing you meaningful asset information with very little configuration effort. Your SDDM information is secured in several different ways. First you'll notice is the login authentication, which can be controlled either through the provisioning of internal SDDM profiles or through your organization's AD federation tools. Each tenant, each company that uses the cloud product is given an account name, and each user has their own personal username. This is a public computer checkbox. If unchecked, will just prompt you for your password afterwards. If it is checked, then you'll get the full account name, username, and password fields available. Once we log in, we come to the main overview page. What you're seeing on this overview page is a summarized view of all the data you've collected for the services you've mapped. It's the end result of your asset discovery efforts. Each card represents a business service that your organization has mapped to its various component parts. The configurations have been baselined, so what you see on this page is all the changes. That way you can reconcile your change management requests against this, so you can verify the effectiveness of a change or possibly identify changes that were not properly approved. This is where you might start when looking to see if there are any rogue or BYOD devices that are newly connected to the network that might be causing problems, like a DHCP server or unapproved wireless AP. Each of these service cards contain information on how many approved dependencies there are in there, any new activity, any new talkers on to any of the component parts, and any of the baseline items that have stopped talking for a while. This might trigger an alert, email, or a pop-up that warns you. Or it may just be that there were some original dependencies that are no longer necessary to the everyday delivery of the service. We can drill down into these cards by coming here, and you can see that we have options to edit and to view the baseline map and to view traffic and dependency lists. Let's have a look at the baseline map real quick. So a baseline map is not quite what is created initially by SDDM. This is what, after a review of all the devices that were identified, your applications people might say these are the ones that are critical for the delivery of this service. And so components may come and go from here. Once you're in this mapped view, you can easily tell if a certain system goes down, what it might affect. So it's good for change management and figuring out change management windows. And you can see both here on this particular claims processing system, you can see which devices are network devices, which devices are application servers. So we can hide and show different parts by going to the map controls on the right, where you can see that we have display settings, layout and export configuration items, and being able to drill down into the specific items here. So if we go back to display settings, you can, for example, turn on and off the network and just see the application server components. Turn back on. If we've suppressed anything, you turn that back on, you can see more. If you have a device that you want to center on to see what it's talking to or what its dependencies are. You can go here and then the selected item details will pop up, and you can get more information on that device and the ones on the system, whether you want to edit additional information into it or exclude it from the map because it may not be necessary to the baseline. I'm going to step away from the application interface for a moment and take a look at how the complete system is structured. We have over here the SaaS application servers in the SDDM cloud, and over here on-premise within your network environment is our data collection tool or edge device. This is the device that does the active discovery, the polling, the collection of data. It doesn't do any evaluation of the data itself. That's all done over here on the cloud side. We have an image file that you can download and install within a server on your environment. You give it an IP address, you register it with your SDDM SaaS environment, and the collector controls the communication to the cloud app servers. Only secure outbound communications are performed. The SaaS environment never initiates any communications. This device is a collector. You send your NetFlow, your SFlow, your promiscuous data to it, and it both passively monitors that traffic flow, and it also manages the active processes, which are like the device discovery, which may be done through a ping or a variety of calls, and it also handles external API interfaces. Besides these two main elements, the cloud and the internal on-premise collector, the SDDM system also interfaces with a variety of other important tools, such as your email or notification services, so that if a alert needs to be sent, we can get it out to you that way. The dashboards are a vital tool to be watched and monitored in your NOC. And probably one of the greatest benefits is that it can interface with the CMDB within your service management tools. So we're taking these raw assets, building service maps, and we can push them integrated with your service management tools so that your CIs are populated, put into a meaningful dependency mapping view, and as we discussed earlier, that information can be very useful in your change management process for, once you've identified the baseline, to see what deviations from it have occurred, what changes have occurred recently, whether it's verifying an approved change request, identifying a change that was made without approval, or possibly even identifying rogue devices that have no business being on your network at all. So as well as supporting problem management and incident management processes. Now we're ready to get back into the application and see what that traffic looks like and how you can get it into a usable service model. Let's go take a look at the traffic list. Once your edge device is set up, it passively listens to all the flows that are sent to it. Here in the traffic list, we see what amounts to a flow database. So let's expand this out a little bit, and you can see that we've got a lot of things that the edge device has been picking up, and it's sorted, divided up into source and target devices primarily, and the traffic that passes between them. So the source device, or CI, is named when it's first discovered by its IP address, and it also reports back DNS information here if it's available. So we have that for both target and source, but the traffic that passes between them is identified by what port it's come from, what service network service. It participates in whether it's LDAP or NetBIOS or HTTP. A lot of that's based on the port determination. What the average number of packets per session is, and the average size of those packets per session. Also, off to the right here, you see that this was detected by edge device 1. There may be more than one edge device in your network should the architecture of your network demand such a thing, and when it was last updated. So, say for example, you had a forensic challenge here. You needed to figure out the root cause for an incident or a problem, or perhaps you're just looking for something anomalous on the network, like a web server that's pushing out information that may not have been approved or something like that. What would you do? Would you, leaf through thousands and thousands of traffic entries? The easier way would simply be to identify the ports that you'd like to narrow it down to, filter the list, and we can see any servers that are running HTTP services through port 80, port 8080, whatever you think might be working out there. Check that against your approved CI list and your baselines, and you can tell whether they're approved or if you've just stumbled upon a rogue device. Up here we see service entry points under the traffic list, and a service entry point fairly simply indicates the starting point of a process. When we start creating a new baseline or a service group, we start with the most important piece of that business service. It may be that you've got an e-commerce server running out there for your customers to buy things from, or you just have a system where it's easy to identify that there is a lot of clients accessing that. Here's an example of a server that has a lot of clients attaching to it. Might be a good place to start looking at a service. Looking at the DNS names here, we can recognize that this is our incident management system, where our tickets come in from our customers. So I can identify that as a good service entry point for a new service group. Clicking on New Service Group brings up the Edit Service Group page, where I can give it a name. So we'll call it something appropriate and temporary, like Incident Management Test. And we can specify how much or how little information we need pulled back into this. What's going to happen is the data takes a few minutes to get put together to build this service group, and if we can exclude as much as possible and keep it pared down, it'll update faster, and we'll have a tighter, more focused service group without a lot of extra stuff. So you can add exclusions or include certain specific otherwise excluded IP ranges or whatever, and you can limit the number of hops that you want. If you know everything is within a certain server subnet, just leave it at 1 hop. If it covers your central data center and some regional data centers, you might want to add a hop or two onto that count. And then we go down here, run save, and the system starts building the rules and the structures that are necessary for populating out the new service group. So in a few minutes we'll start to see items show up for our new service group that start adding dependencies on there. If we go click into this and refresh and look at the dependency list, we'll see that a few have started to appear. Looks like we've got possibly a few hundred. So a dependency is a combination of a source and a target, and it may only mean that you have 2 servers. Even if you have hundreds of dependencies here, you may only have 2 CIs involved. It could just be different traffic on different ports coming through here. You have TCP traffic on 298.06, on 48464. These are all different dependencies when you compile these up together. So if we check all these, we could add them to the baseline map and apply that, and we're ready to go view our new map. Now it's going to come up a little messy. We might want to zoom out and rearrange it so it's a little more logical to our tastes. Put the most active server in the middle and run everything else off of it like a spoke, or however it goes, but this is what it's discovered in the first minute of the dependency tracking and associating. Over time, it may pick up more and items may drop out. So this is where it becomes an administrative task to figure out which of these elements are key to providing that service. And if you get rid of all the clutter and be able to tell what's critical, you'll know that if one thing goes down, part or all of your service is going to be unavailable for a certain amount of time, which is key to your change management and change management window determination. Well, now you've seen the core capabilities and elements that make up the FireScope, the SDDM program. There's so much more that this system can do. Make sure to come back and see other demonstrations regarding vCenter interrogation. We can do network topology mapping, load balancer discovery. And those are just a few of the benefits that FireScope SDDM can provide to you and your organization. Until then, thank you for watching, and we look forward to presenting to you again.